Hello and welcome back to yet another episode. Myself, Fazira Razak Hamza, Assistant Professor in PG Department of Computer Science, and I'm here to present on the course Computer Graphics. In the last episode, we were discussing about filling polygons. So I have mentioned three algorithms for filling. The first one was scanline polygon fill algorithm, which we completed in the last episode. And in this episode, I'm going to discuss about boundary fill algorithm and flood fill algorithm. So let's move on to boundary fill algorithm. Boundary fill algorithm starts at a pixel inside the polygon to be filled and paints the interior proceeding outwards towards the boundary. So, this algorithm works only if the color with which the region has to be filled and the color of the boundary of the region are different. If the boundary is of one single color, this approach proceeds outwards pixel by pixel until it hits the boundary of the region. So, boundary fill algorithm is recursive in nature. Now, boundary fill algorithm takes three inputs. It takes an interior point x, y as the current pixel, a fill color and a boundary color as the input. So the algorithm starts by checking the color of x, y, that is the current pixel. If its color is not equal to the fill color and the boundary color, then it is painted with the fill color and the function is called for all the neighbors of the current pixel x, y. If a point is found to be of fill color or of boundary color, the function does not call its neighbors and returns. So this process continues until all points up to the boundary color for the region have been tested. So the boundary fill algorithm can be implemented in two different ways, that is 4 connected pixels and 8 connected pixels. Let's see what are this. So first we'll move on to 4 connected pixels. Okay. After painting a pixel, the function is called for 4 neighboring pixels. These are the pixel positions that are right, left, above and below the current pixel. Areas filled by this method are called 4 connected. Now let's see the figure. See, this is the current pixel x, y. To the right, we will take x, y plus 1. To the left, the neighboring pixel is x, y minus 1. And above, the neighboring pixel is x minus 1, y. And below, the neighboring pixel is x plus 1, y. This is how 4 connected pixel fill colors in the neighboring pixels or fill colors in a specified polygon. Let's move on to the algorithm. 4 connected pixels algorithm. See, I have called for a function that is boundary fill 4, which is used to fill the polygon or the area of the polygon with color. So boundary fill 4 is specified with the current pixel value, that is x and y, is of integer type, then a fill color of integer type and a boundary color of integer type. Now I'll check for a condition, that is with the current pixel. If the get pixel x, y not equal to boundary color and a get pixel x, y not equal to fill color, then we have to put the pixel x, y with the fill color value. Then I have to call for the neighbors of the current pixel x, y. So I will call the first right neighbor, that is x plus 1, y, and I will fill up to the boundary color. Then the left neighboring pixel, that is x, y plus 1, and I will fill up to the boundary color. Then the above neighboring pixel x minus 1, y and below neighboring pixel x, y minus 1. This is the algorithm for 4 connected pixels. We are only choosing for 4 neighboring pixels. Now, I am moving on to the next implementation method of boundary fill algorithm, that is 8 connected pixels. So, more complex figures are filled using this approach. The pixels to be tested are the 8 neighboring pixels, the pixel on the right, left, above, below, and the 4 diagonal pixels. Areas filled by this method are called 8 connected because we are choosing for 8 neighboring pixel values. So now this is my current pixel. To the right I am taking x comma y plus 1. To the left I am taking x comma y minus 1. And above pixel, neighboring pixel x minus 1 comma y, and below neighboring pixel x plus 1 comma y, and the 4 diagonal neighboring pixels. So to completely fill a polygon we need, or a complex polygon type can be filled using 8 connected pixels. So now let's move on to the algorithm. Here I have defined a function of boundary fill 8 with current pixel x comma y, then an integer value for fill color and an integer value for boundary color. Now I'll check for the get pixel value. If the get pixel x comma y value is not equal to boundary color and not equal to fill color, I have to fill the polygon. How I can fill? I'll fill first the get pixel of x comma y with fill color. Then I will call for the 8 neighboring pixels. So first I am calling the right pixel, that is x plus 1 comma y. Then the left neighboring pixel, that is x comma y plus 1. Above neighboring pixel x minus 1 comma y, and below neighboring pixel x comma y minus 1. Then I will call for the pixels in the neighboring pixels in the diagonal positions, that is x minus 1 comma y minus 1, x minus 1 comma y plus 1, x plus 1 comma y minus 1, and x plus 1 comma y plus 1, and I will fill up to the boundary color is reached. This is the 8 connected pixels algorithm. Now I will show you an example. See, this is an example figure. See, this is an example polygon. We have placed it on a grid, rectangular grid, and I have chosen a, see, let us take a figure with the boundary color as green. Okay, I have set the boundary color as green and the fill color as red. So half of a portion of the polygon is being filled with red color. Okay, here the 4 connected method fails to fill this figure completely. Why? Because diagonal position can be colored with the 4 connected pixel algorithm. So this figure will be efficiently filled using the 8 connected technique. So 8 connected technique is more efficient than 4 connected technique. Now I'll move on to the next algorithm, that is flood fill algorithm. With this algorithm, we can recolor an area that is not defined within a single color boundary. So in this, we can paint such areas by replacing a color instead of searching for a boundary color value. This procedure can be used to reduce storage requirements of the stack by filling pixel stacks. So that is, we'll look on to the algorithm and we'll understand how this works. So here we are not specifying any boundaries. Instead, we are simply filling with the previous color. So I've started with a function that is flood fill 4, and I've chosen the current pixel, that is x comma y, then a fill color, then an old color in integer. Then I'll check for the get pixel value. Get pixel of x comma y equal to old color. If it is set to old color, I'll fill the x comma y with the fill color, that is the old color itself. Then I'll choose the 4 neighboring pixels with the 4 connected pixel algorithm, x plus 1 comma y, x minus 1 comma y, x comma y plus 1, and x comma y minus 1, and I will fill this with the old color, and I will never check for a boundary. Okay, so the difference is that in flood fill, all the connected pixels of a selected color get replaced by a fill color. On the other hand, in boundary fill, the program stops when a color boundary is found. This is the difference between boundary fill algorithm and flood fill algorithm. Thank you. Thank you so much for listening.